Hello guys, today we shall be going about this pneumatic electro trainer, and there are number of components which are attached to all this big panel. You have a PLC panel on the top, you have pneumatic panel on the bottom, and I will be briefing you on the working of each and every part of this without giving any demo. This is just the way I want to tell you what happens at what point. So what I will be doing right now is introducing you to the concept that you have a compressor, and from the compressor you will have one pipe coming and entering at this point of, this is called FRL unit. So perhaps you can see from here, this is FRL unit. This is my favorite quiz question. F stands for filter. So this is the point you are having filter. So the particles, the dust particles and anything which is not very much desirable is filtered out here. This R stands for regulator. So you want to regulate the pressure to certain psi, 20 psi, 30 psi. And then this air, it needs to be lubricated, because this air will be going to all these components like cylinders and so on. So they need a regular lubrication. So we don't want them to be rusted or get jammed on some account. So from this filter, regulator and lubricant unit, the air goes to this distribution point, and this distribution point, as you can see, it has number of valves, and you can open any number of valves at a time, 1, 2, 3 or none. And if you want more, this gets connected to yet another distribution manifold, and in all you can have maximum of, in this unit, 4 here and 4 here. Total of 8 valves are there which can be used. You can cut off the supply from here or you can open it. So this is called manifold. In between, you want to have a better picture, you can always, from any point, you can always give an input to this valve and take the output back from this, or you can have a differential output for the pressure over here. So that will give you the gauge pressure. Whatsoever is there, you want to know the gauge pressure, you can get it from here. Now we come to certain points, and these are very, very important points to know, because as you can see, there are number of points written over here. The first thing I will come across is, you can very well see clearly, it is 3x2 valve. What do you mean by 3x2 valve? Because we will have 5x2 valve and 5x3 valves. So what do you mean by 3x2 valve? 3x2 valve is very, very simple, because it has one input and 2 outputs. You have 2 outputs over here. So that is why what we see by 3x2. So total number of ports are 3. One is used for input and output ports are 2. You can see this is one port and this is another port. So these are 2 ports. So total number of ports are 3 and output are 2. That's why it's called 3x2. So it means that you have this lever. You can always move this lever left or right. So you can move it left or right. So that's what we are going to do over here, that we're going to go input. Once it's connected, it's moved to the right part, this input will be connected to this output. And if it is connected to the left point, it's shifted, it's a hand lever, you shift it to the left, then this input gets connected to this left port. But the best part of this, or the worst part of this, is that there are no exhaust ports. It means that this will get connected to this, and this will remain at the same, it will get disconnected, it will remain at the same pressure. It will not exhaust back to 0, right? So you don't have any exhaust port. So this is the best part or the worst part over here. That's why it's called 3x2 port. Now very similar to this is 5x2. This is, you can see, you can read, it's 5x3. It's 5x3 lever. But before we go to 5x3, we will go to 5x2 valve. So this for example is 5 by 2 wall. So I will come to 5 by 3 also, but in 5 by 2 you can see there are 5 walls. Actually you can see only one wall over here, input, one output and one output over here, but what is not visible but actually is built in somewhere here is you have one exhaust wall connected to this and one exhaust wall connected to this. It means that when this lever is on the right hand side, this input is connected to output and this output gets connected to the exhaust. When this lever is on the right side, then I repeat, this is connected to this and this is connected to exhaust. If I move this lever to left side, towards left, then what will happen? This input will get connected to this output, and whatsoever is the stored pressure in this, it will be exhausted. It will be exhausted from the inbuilt exhaust valve over here. So this is a way better than 3 by 2 that you have exhaust valve. In 3 by 2 there were no exhaust valve, so whatsoever was the pressure, the last pressure remains. Here the last pressure, it is exhausted. Now coming to 5 by 3 valve, as you see 5 by 3 valve, it looks like 5 by 2 valve only. You can have internal construction of this also. Here again you have input and you have 2 outputs and you have 2 exhausts, right? So total number of ports are 5 and the output ports are 2. So it should be 5 by 2, but it is 5 by 3 because this lever can be made to move either to right or it can be made to move to left, as you can see, or it can be made to you can actually bring it somewhere in the middle also. So this is the third position. So it's right, left and middle. So what do you mean by middle? So 5 by 2, it's going to act like 5 by 2, just the way I had explained earlier, that if the lever is on the right side, then this input port will be connected to the right port and the left port will be connected to exhaust. When the lever is on the left side, then the input will be connected to the left part of the port over here and the right will be connected to exhaust. But when it is in the middle, then what happens is that the input is not connected to any of the two and all the output ports are also not connected to exhaust. It means that both remain the way they were without any input, so it remains, it's an intermediate state is also there. So that's why it's called 5 by 3, because you have 3 positions when it's connected to left, when it's connected to right, when none of the two are connected and both are not, so you can stop the things where they are. So what is to be stopped? For example, you have this, you can read over here, double acting cylinder. So in double acting cylinder, as you can see, these are the limit switches, this limit switch for example, and this limit switch is here. So you will connect the output of this 5 by 3 wall to this point and the second wall to this point, right? So what will happen when you press this lever, when you push it to left, then this point will get connected and this point will get connected, so the piston will move on to one side. When you connect it onto the other port, you press the lever on the other side, this piston will move on the other side. And if you, while it was moving, you just hold it in the middle position, 5 by 3 middle position, then it will stop in the middle itself. This is the best part. So you want to stop in the middle, you can do so. You cannot do this by 5 by 2 wall, because in 5 by 2 wall it's going to move either to the extreme right or to the extreme left. It cannot be stopped in the middle because either it is connected to the left port or it's connected to the right port. It's never having a third position where both the output ports are not connected to the supply. So that's the advantage. So if you are able to work upon this 5x3 valve connected to double acting cylinder, then everything is covered. So these are the slight variants. You have double acting valve with limit switch, you have double acting valve with some roller switch, you have other kind of double acting valve with another switch kind of here. You also have a single acting cylinder where it's spring driven. It means that it will go to left under the action of pressure but will come back by itself, by the spring. And then you can, instead of having lever, you can have push button, as you can see from the top. This is a push button, or you can activate it with some kind of solenoid. Solenoid means that instead of having a lever, you have a solenoid. So you give some 5 volt supply and you turn the supply on, and instead of turning the lever on, you can turn the supply on. And this supply you can give either through a regular switch, manually operated, or you can even give it through the PLC. That is, the PLC will turn the entire thing on and off. This is what actually happens in industry. You don't have all those levers to turn the things on and off. Everything is automatically controlled by this PLC. The PLC is going to give the digital output. This digital output will come from here to the solenoid valve over here. The solenoid valve, this solenoid switch will turn the solenoid valve and will connect at this point either to left or to right. This can be given either to single acting cylinder or to double acting cylinder, or you can get any feedback from here and so on and so forth. So this, my dear friends, is in totality the description of the electro pneumatic trainer. It's advanced trainer, it's having PLC in it and all these things. So in the next video we will give demonstration of only one thing, that is we will be making use of 5x3 valve on a double acting cylinder, and rest of the things are quite self-explanatory. So if at all you have time, anytime, you can visit the lab and play with your hands. You can already have, suppose you already have the feel of it. I hope you have enjoyed this part of the learning. Till see you. Bye bye.